How we doing, guys? We're looking today at differentiation by rule. So this is a follow-on from differentiation from first principles. I'm working at a text and test 7, and we're on pages 67, 68, 69. So you might have spotted with differentiation from first principles that there's a pattern that if you have an index up here, the rule is, well, you multiply this number here by that index, so you get 6, and then you say x to the power of, you reduce that index by 1, so 2 minus 1 is 1. Okay, so that's dy dx of this function y equals 3x squared is just 6x. So it's a much faster way of getting to your derivative. Now, you still need to be able to differentiate from first principles, but this obviously will save us a lot of time for most problems. This one here, if y is 4x cubed, 4 times 3 is going to be 12x reduced 3 by 1 squared. And what you'll sometimes also see is f of x is 4x cubed, f prime of x is 12x squared. So these are equivalent notations. Okay, these two pieces of notation here are equivalent. And if you're differentiating a constant like y equals 4, well, that line, if you look at it there, that's it dotted along there. And if you remember that the differential of a function is the slope of a tangent, well, any tangent to that line is going to be the line itself. And the slope is going to be 0. Alternatively, as x changes, y does not change. So there is no change in y with respect to x. But either way, if y is 4, dy dx is always going to be 0. And anytime there's a constant, you'll see it's a 0. So looking at question 1, part 4 and part 6 is what we're going to look at here. So this one here, x cubed minus 8x squared plus 2. And this one here, 2x cubed plus x squared plus 1 over x squared. So the first one, if you want to differentiate that, well, 3 times, there's a 1 there. Sorry, that shouldn't have been a 3. So that's like 3 times 1. You get 3x reduced the power by 1 to the power of 2. Take away 8x. Now, x by itself is like x to the power of 1. So multiply by 1, you just get 8. Reduce the power by 1, you get x to the 0. But anything to the power of 0 is 1. So that's just going to be 3x squared minus 8x. This one here, if you notice, you've got something funny here. Our rule depends on us having an index. So let's rewrite that as 2x cubed plus x squared plus x to the power of, well, 1 over x squared is the same as x to the power of minus 2. If you'll remember that from doing indices in the third algebra chapter, the one that we did this year. So the differential dy dx is going to be 3 by 2 is 6x reduced by 1 to the power of 2 plus 2 by 1 is 2x to the power of 1, which is just x. Now multiply by minus 2, you get minus 2x to the power of, reduced by 1, you get minus 3. And sometimes you could also write that as 6x squared plus 2x minus 2 over x cubed. Okay, so there's a few questions with funny indices in this exercise, like this one. We're going to skip over them for the moment. We'll come back and have a proper look at them in class another time. Question 11 says, find the slope of the tangent to this curve, x squared minus 2x plus 3, at the point 2, 3. Now, 2, 3 is not on the curve. They mean 2 minus 3. So you can change that unless it's been changed in your book. So here's the curve. Okay, the curve is x squared minus 2x minus 3. And it's at this point we want to find the slope of this tangent here. At this point, 2 minus 3. Well, the slope of a tangent is just what we did in deriving our first principles formula. It was finding the slope of the tangent line. So that's what the derivative is. it's dy dx, is the slope of a tangent or the rate at which the function is changing at a given point, in this case at x equals 2, or the slope of the tangent at x equals 2. And you can imagine if I move that tangent around, that slope is going to change. So here it's got one slope, but as I look at a different point in my function, the tangent is always going to have a different slope at different points. So I'm going to say, all I'm trying to do here is find dy dx, which is 2x minus 2, but at x equals 2. Okay, our point there is 2 minus 3. So it's the x value is 2. Well, the dy dx there, the slope of that tangent is going to be 2 times 2 minus 2, which is 2. Okay, so this line that I've drawn here, if you did a nice accurate diagram, you get a slope of 2 for that. Question 19 then is the last one we're going to look at. Question 19 says, find the point on this curve, 2x squared minus 8x plus 3, where the tangent is parallel to this line, 4x minus y plus 2 equals 0. So we'll start off with that line, 4x minus y plus 2 equals 0, can be rewritten as y equals 4x plus 2. So from coordinate geometry, the line, you can see the slope of that line is 4. Here's our curve, 2x squared minus 8x plus 3. Here's our line, 4x plus 2. So we're looking for a point on the curve where the tangent is the same as this. It's the same slope. Okay, well, the slope of a tangent we know is just dy dx. So we're saying, where is dy dx of this function going to equal 4? So we say dy dx is 2 times 2 is 4x to the power of reduced by 1. So 2 minus 1 is 1. Minus 8. X to the power of 1 just becomes x to the power of 0, which is just x. And if you like, you can say a plus 0 for that 3, but you don't have to. And we need that dy dx, that slope of the tangent, to equal 4. Well, that will happen when 4x is 12 and x is 3. Okay, so coming back to our coordinate, we can say, well, y there, or to our function, y is going to be 2 times 3 squared minus 8 times 3 plus 3. And that occurs, that is minus 4 is what you get there. Minus 1, 2, 3, minus 3. Sorry, I've done all these beforehand. Let's just check that. 2 9s 18, take away 3 8s are 24, plus 3 is 21, take away 24 is minus 3. So it's at this point here when x is 3 and y is minus 3. That's our answer. You can see that in our diagram, if I can find my ruler, is that at this point, 3 minus 3, the slope of the tangent there, now it's a rough diagram, but the slope of the tangent looks all right, like it should be parallel to that. Parallel to this slope here, okay? It's 2 places where you have a slope of 4. Well, sorry, 1 place in our function, and this line has a slope of 4 as well. Now, I'm going to ask you tonight, please, to finish question 1 and give question 12 a go. And in class tomorrow, we're going to do 3, 9, 13, 14, 18, and 20. Now, we'll probably spend 2 classes on this. We'll look at those tricky indices ones after we get comfortable with the rule. Okay, so I'll see you tomorrow. Bye-bye.